In this video, I'm going to review linear equations and some information about what we call equations that do not have solutions. So this video is optional. If you feel like you have a really good handle on linear equations, then you may go ahead and skip it. So as I said, we're going to discuss linear equations, specifically how to solve them. So we'll start with an example, and we'll start with a little bit of a more difficult example because this is something you are already familiar with. So my first example is going to be 6x plus 4 minus 2 times the quantity x minus 1 is equal to 2x plus 20. Okay, so we get to apply the properties of real numbers that we discussed in the last video. So I'm going to distribute this 6 to the x and to the 4. So I have 6x plus 6 times 4. And then I'm going to distribute this negative 2 to both the x and the negative 1. So that's minus 2x, and then also subtract, or a negative times the negative will be addition of a 2. And that's equal to 2x plus 2. Next, we can go ahead and combine like terms. And we said like terms are ones that have the same variable and exponent, and or they could be constants. So we have in this case a negative 24 and a positive 2. So we'll go ahead and combine those on this side. So I have 6x subtract 2x, which gives me 4x, and then I have a 24 plus 2, which is a plus 26, and we'll still leave that equal to the 2x plus 20. Okay, and then we're going to go ahead and try to isolate the variable. So I'm going to subtract 2x from this side, and whatever I do to one side, I do to the other. I'm always trying to keep my equations balanced, and this will be important later on as well. So I can remove it from this side, and it's gone from this side. And so on this side I have a 2x, and on this side I have my constant, which is a negative 6. I'll finish up by dividing both sides by a 2, and that means that x is equal to negative 3. And then of course I should go ahead and check it, and you can check this using the methods that we talked about on the Inspire. The second example that I'd like to talk about is 4x minus the quantity 2x minus 1 is equal to x plus 5 plus x minus 6. So again, we'll go through the same process of using the distributive property, combining like terms, and then we'll go, so I'm going to go ahead and combine these two here. So I have a 2x and plus 1 is equal to 2x minus 1. Now, if I were to go a little bit further, if I move my 2x's over, I would get that 0x or 0, and then I'd have positive 1 equals negative 1. I can look at it from this point, and I can see that 2x plus 1 is not equal to 2x minus 1, and I could stop there. If I had gone a little further, so let's say I had the 2x plus 1 equals 2x minus 1, and I was subtracting the 2x from each side, I would end up with 1 is equal to negative 1, which again we know is not possible. So we would say that's not equal. And so this equation is what we would call an inconsistent equation, meaning there's no solution. So we would identify that as inconsistent. Okay, and then I'd like to spend time on just one more example. And the last example is 10x minus 4 divided by 2 plus 7 is equal to 5 times the quantity x plus 1. So we'll go through the process of beginning to solve. We can get rid of the fraction by dividing 2 into 10x, and so we can use that property we talked about yesterday. So let's show the little thinking bubble over here. We'd have 10x divided by 2 minus 4 divided by 2, and so that's essentially that distributive property we reviewed yesterday. So I end up with a 5x minus 2 plus 7 is equal to 5x plus 5. Okay, and so I'm going to go ahead and combine my like terms on this side, and I have 5x plus 5 is equal to 5x plus 5. And if you notice, you could stop here because 5x plus 5 is always going to equal 5x plus 5. It doesn't matter what we plug in for x, right? Or if I were to take it a step further, like the last example, if I subtract 5x from each side, I get 5 equals 5, which 5 equals 5 is what we would call an identity.